Hello everyone and welcome back. So today we are going to learn a very hot topic on vector space or linear algebra, which is linear dependence and independence. So we'll see that when some vectors from a vector space are said to be linearly dependent and independent. Okay, so let's get started. Suppose capital V is a vector space. यहाँ पे capital V क्या है? vector space over the field F. Okay, over the field F. So V is a vector space over the field F. Then the vectors, अभी हम लोग capital V से कुछ vectors लेंगे. We'll take some vectors, okay, from capital V, V1, V2 and then Vn. So these are all elements from capital V. Now these particular vectors are said to be linearly dependent. Okay, these vectors are said to be linearly dependent over F if there exist some scalars a1, a2 and then an. So यहाँ पे जितना vectors होगा उतना हमें scalar चाहिए. Now this is very important. You see what is written here. Not all zero. Okay, not all zero. So we are talking about the scalars. These scalars, no, these scalars should not be zero all together. So what does it mean? पहले हमें क्या करना होगा, जो vectors है उस वेक्टर्स को कुछ स्केलर के साथ एक कॉम्बिनेशन बनाना होगा. a1 v1 प्लस a2 v2 प्लस एंड देन an vn is equals to how much? 0 bar. So what is 0 bar? 0 bar is the additive identity of the vector space. Okay, so this we already know from the very first lecture. Now see, we have to, this is also a linear combination, right? The left hand side is also a linear combination. So in our earlier video, you know what is linear combination. So linear combination is combination of some scalar and vector. Now after that, what to do? We have to solve this equation. After solving, what to find? Vectors will be given to us. We have to find the values of a1, a2 and then an. So these values we have to find a1, then a2 and similarly what? An. And then we have to observe what are the values of these scalars a. Now what is written here? Not all zero. Suppose मान लीजिए a1, a2, a3 किसी स्केलर का भी वैल्यू जीरो नहीं है. So then we say that the vectors are what? Linearly dependent. Suppose some scalars are zero and some are not zero. Then also the vectors are what? Linearly dependent. Suppose only one vector is non-zero and all the other vectors are non-zero. Then also it is what? Linearly dependent. So उसका मतलब क्या है? If all vectors are not zero together, सपोज मान लीजिए सब जीरो है तो केस अलग है. बट इफ सपोज वन इज एटलीस्ट वन इज नॉन जीरो बट ऑल द वेक्टर्स आर जीरो, देन वी से दैट इफ वन स्केलर इज जीरो एंड ऑल द अदर स्केलर्स आर सपोज नॉट इक्वल टू जीरो, देन वी से दैट द वेक्टर्स आर व्हाट? लिनियरली डिपेंडेंट. ओके, सो जस्ट रिमेंबर दिस थिंग. जितना भी यहाँ पे स्केलर है a1, a2, a3 सारा जीरो नहीं होगा, एक साथ जीरो नहीं होगा. या इफ ऑल आर non-zero, then is very good, but if some zero, some non-zero, then also you say that the vectors are what? Linearly dependent. But suppose सारा स्केलर जीरो है, a1 is zero, a2 is zero, and then an is zero. So in examples we'll see how some scalars are non-zero and some when all the scalars are zero. Suppose if it is the case that all the scalars are zero, then we say that the vectors are linearly independent. Okay, so here the prime things are the scalars. We have to find the values of scalars. If all scalars are zero, then vectors are linearly independent. And if the scalars are not zero together, then the vectors are linearly what? Dependent. Okay, now let us take one example. See, three vectors are given. So we have to check that they are linearly dependent or independent. So how to start? Since there are since there are three vectors, so we need three scalars. Let suppose alpha, beta and then gamma belongs to, here no vector space is given, so let us write like this, on r cube of r. So r cube means what? R cube is three-dimensional. So sometimes 3 is in the power, sometimes 3 in the suffix, so all are same. So these are scalars such that now what to do? We have to make a combination, okay, such that alpha v1 plus beta v2 plus gamma v3 is equals to हमें क्या पकड़ना है 0 bar. Then what we'll do, now we'll put the values of v1. v1 is our 1 2 1, and then beta into 3 1 5, and then gamma into 3 minus 4, and then 7 is right side is 0 bar. So this 0 bar is also 3-dimensional. Okay, 0 bar is also 3-dimensional. So later I'll see, I'll say what is this. So now just combine them. Alpha into 1 plus 3 beta, then 3 gamma. All the first element we have to write together. Now the second element, alpha into 2 plus beta into 1, gamma into minus 4, so minus 4 gamma, and then alpha 5 beta 7 gamma. Now see, this is 0 bar, so 0 bar is additive identity of r cube. So since r cube, so it is also 3-dimensional, so the value of 0 bar will be 0 0 0. Okay, now what to do, we have to compare alpha 3 beta 3 gamma is equals to 0, twice alpha beta 4 gamma equals to 0, and then alpha 5 beta 7 gamma equals to 0. So here we are getting 3 equation. Okay, 3 different equation. So let it be equation number 1, this is equation number 2, and this is equation number 3. Now what to do, we have to solve these 3 equation. Okay, after solving these 3 equation, we have to find the value of alpha, beta, and then what, gamma. Now how to solve them? Suppose here we see 3 gamma, here we see 4 gamma. So first let us eliminate gamma from first 2 equation. So how to eliminate? In this particular equation with gamma we have 3, and here with gamma we have 4. So let us multiply this term by 4 and this particular term by 3, so that it will become 12 gamma. This is also become 12 gamma. Then gamma gamma will be cancelled out. So equation 1 into 4 plus equation 2 into 3. Okay, just calculate it. The calculation you can do by any method as you wish. Okay, sometimes by using matrix method also you can solve these things. By Cramer's rule also you can solve this thing. So it is up to you. Okay, now if we do this 4 into alpha, so here it is 4 into alpha and then 6, so it will be 10 alpha. Okay, this will become 10 alpha. Then we have to multiply this with 4, it is 12 beta, then 3 beta plus 15 beta, and gamma will be cancelled out. So it is 15. Okay, so now it's 2 alpha plus 3 beta equals to 0. Now see, here we cannot get the value of alpha and beta. Now from this, if you see, you'll see that alpha is dependent on beta. Okay, so alpha is dependent on beta. If this is the case, then we cannot find the values of alpha and beta together, because one is dependent on other. Similarly, if you take some other equation, suppose 2 and 3 or 1 and 3, you'll get a similar relation that one vector will be dependent on other. Since beta is dependent on alpha, so the scalars are not all 0. Okay, non-zero, because alpha का वैल्यू सपोज 1 है तो बीटा इज इक्वल टू 1, देन अल्फा कुछ अलग होगा, बीटा का वैल्यू चेंज होगा तो ये भी चेंज होगा. सो यहाँ पे डिफरेंट वैल्यूज आएगा. सो ये जीरो नहीं है. सो सिंस द स्केलर्स आर नॉट जीरो, व्हाट इज द डेफिनेशन? अगर सारा स्केलर जीरो नहीं है तो वेक्टर्स क्या होगा? लीनियरली डिपेंडेंट. सो v1 v2 एंड v3 आर व्हाट? लीनियरली डिपेंडेंट. ओके, सो बहुत ही सिंपल है प्रॉब्लम. Now let us take one more example. Show that the system of 3 vectors, यहाँ पे 3 वेक्टर है. Suppose this is v1, this is v1, this is v2, and this one is suppose v3. Okay, three vectors दिया हुआ है. We have to show that they are linearly independent. So if they are linearly independent, means here all the scalar will be 0. And what is the field here? The field is rational number. Okay, so let a1, a2, a3 belongs to Q. So scalar we can take anything such that a1 v1, a2 v2, and then a3 v3 equals to how much? 0 bar. So a1 into, now v1 is how much? 1 2 0. Then a2 into, what is v2? 0 3 1. And then a3 into, it's minus 1 0 and then 1, and right side we have 0 bar. Now we'll combine them and write together. So what is the first element? a1, here it will be 0 minus a3. Okay, then 2a1 plus 3a2, and then a3 is 0, this is 0. Then here a1 is 0, a2 plus a3, and right side what will write? 0 0 0, since it is 3 dimensional. If it is 2 dimensional, then you have to write 0 comma 0. Now let us compare that. After comparing, a1 minus a3 equal to 0, then 2a1 plus 3a2 equals to 0, and then a2 plus a3 equals to how much? 0. Now we have to solve them. Okay, so this is equation number 1, equation number 2, and this is equation number 3. How will solve them? How we can solve the equation? So you can use any method. Okay, so simple elimination method also we can use it. So if we eliminate, suppose 1 plus 3 implies, so if we add equation 1 and equation 3, you see a3 cancel out. So what we'll get? a1 plus a2 equals to 0. So new equation you are getting. This is equation number what? Suppose 4. Now equation 2 minus 2 into equation 4. So if we do this, then what we'll get? In equation 2, what is the first term? 2a1. And in equation 4, what is the first term? a1. So if we multiply it by 2, so 2a1 minus 2a1, it will cancel. Then what we'll get? 3a2 minus 2 into a2. 2 into a2 equals to 0. So see, from here a2 equal to how much? 0. The first value we are getting here. So a2 equals to what? 0. So if we put a2 here, suppose if we put a2 here, if we put a2, then our a3 will become 0. a3 is 0. Okay, and if we put a3 here, this particular here, so then a1 is equals to how much? 0. So a1 is 0, a2 is 0, and then a3 is also 0. So here all the scalars are 0. Since a1, a2, a3 are 0, so v1, v2, and then v3 are what? Are linearly independent. Okay, here they are linearly independent. This is very simple. Okay, now it's a little bit different type of problem. Two vectors are given. Suppose this is our v1 and this is v2. Now it is v2 affair. So v2 means, see, two dimensional, two elements are there. So it is already given that they are linearly dependent. Okay, so it's given that they are linearly independent. So if they are linearly dependent, then what to show? We have to show that this particular condition, a1 b2 minus a2 b1 equals to how much? 0. Okay, a1 b2 minus a2 b1 equals to 0. So there is one more condition by finding the determinant value also, na? So we can, all the other problem you can do like this. See, in this particular example, if vectors are linearly dependent, then determinant value, suppose this is delta, determinant value equals to 0. If vectors are li, then the determinant value is not equals to 0. So what does it mean? See, in the first problem, here the vectors are linearly dependent. So if the vectors are linearly dependent, then you can do like this also, delta. So what are the first coefficient? 1 3 3. So 1 3 3, this is another method. And then here 2 1 minus 4, 2 1 minus 4. From the third equation, what we will get? 1 5 and then 7. Just you break it, break the determinant, what you will get? 0. So if the determinant value of all the coefficient of the scalars is 0, if the determinant value is 0, then you can directly write that this is what? Dependent. So this is also very easy. Just break the determinant. If it is 0, If the value is 0, then linearly dependent. If it is not equal to 0, then it is linearly independent. See, in the second problem, here what we get, all the scalars are 0. So if for this particular problem, our determinant will be what? What is the first equation? 1. So it will be 1, 0, minus 1. Then 0, 2, 3. And then, now here A1 is 2, na? So it is 2, 0, 3, and then 0, 1, 1. If you break it, we will see that this is not equal to 0. So if the determinant value is not equal to 0, that means the vectors are what? Li. So any method you can take. So here we'll take this particular method. It is given that the vectors are what? LD, linearly dependent. Since A1, A2 and B1, B2 are linearly dependent. So since they are linearly dependent, so what we can write? So we can write the coefficient, which is A1, A2, and then what? B1, B2 is what? Equals to 0. Now just simply break the determinant. It will be A1, B2 minus what? A2, B1 is equals to how much? 0. Okay. So this is very simple. Or before writing this particular part, suppose before writing this particular part, you can start like this also, because in some book you will find the solution like this. Let us take two scalar. Let alpha, beta belongs to what? F. Be two scalars such that, what is the field here? Anything is given? Okay, F. Such that alpha V1 plus beta V2 equals to what? 0 bar. Then alpha V1 is our A1, A2, and then beta into V2 is what? B1, B2 is equals to 0 bar. So if you combine them, we'll get two equation: A alpha 1, beta B1, alpha A2, and then beta B2 equals to, what will be the right hand side? 0, 0. So just compare two equation, you will get alpha A1, beta B1 equals to 0, alpha A2, beta B2 equals to 0. So after that, what to write? Since we are getting two different equation here, so finally we'll write, since the vectors are what? Since the vectors are linearly dependent, so eliminating alpha and beta, we get. So how to eliminate alpha, beta? So let us write the coefficient here: A1, B1, and then A2, B2. How to eliminate? This will become 0. So if we break it, again you see A1, B2 minus A2, B1 equal to 0. Okay. So suppose if it's a 1 mark problem, so directly you write this particular condition. Okay. But if it is 2-3 marks, then you can write in detail. So I hope linearly dependent and independent is very much clear to all of you, because it's very simple. Okay. It's basically, it is depending on the scalars. If the scalars are all 0, then linearly independent. If all are not 0, then independent. Okay. So thank you for watching today's video, and if you like my lectures, kindly share and comment in the comment whatever doubt you have, and also subscribe and hit the notification bell so that you get the notification of all my upcoming latest videos. Thank you once again for watching.